Hi everyone. All right, our first video of this distance learning thing we're doing here. I hope that all finds you doing well here. And the topic for today is trigonometric sum and difference formulas. And I have these 6 formulas: sum of sine, difference of sine, sum of cosine, difference of cosine, sum of tangent, difference of tangent. And as you don't have to memorize them, do write them down right now for your just for reference purposes. When you are doing any evaluation or any assessment that I give you, these will be provided for you. So don't despair there. Now the sine of u plus v is sine of u times cosine of v. U is an angle, v is an angle. And you can add them together and talk about the angle, but this is the identity. Sine of u plus v equals sine of u cosine v plus cosine u sine v. Sine of u minus v equals sine u cosine v minus cosine u cosine v. Cosine of u plus v is cosine of u cosine of v minus sine u sine v. Cosine of u minus v, cosine u cosine v plus sine u sine v. You see patterns here. If you had to memorize them, it probably wouldn't be extremely difficult, but that's something I'm going to take off your plate there. Now, we also have tangent formulas here, and they're a little more involved, but you take the tangent of u plus the tangent of v, and that sum is divided by 1 minus the tangent of u times tangent of v. And tangent of u minus v, you subtract tangent of u minus tangent of v, and it's 1 plus tangent u tangent v on the denominator. All right, now, where do we use these things? This is the application, this is the types of problems we do with these formulas. We have problems like cosine of pi over 12. Now, I think you'll agree with me, pi over 12 is not on the unit circle, and we want exact values, and usually that's just what we have on the unit circle. So what I'd like to do is try to write it in a sum. Maybe we have values that are on the unit circle that we could use. Well, what would that be? So I'm thinking twelfths, and one of the things that occurs to me is pi over 4 is 3 pi over 12, because I'm thinking twelfths here, and pi over 3 is 4 pi over 12. And if I were to take pi over 3 minus pi over 4, I'd have 4 pi over 12 minus 3 pi over 12, which is pi over 12. So I'm going to rewrite cosine of pi over 12 as well, I'll write this out. 4 pi over 12 minus 3 pi over 12, which is the cosine of pi over 3 minus pi over 4. Okay, now these are on our unit circle, and we kind of need the cosine and cosine and sine of both those. I'm going to draw. Oh, look how pretty that is. Okay, pi over 4 is right here, and you know the cosine is the square root of 2 over 2, and the sine is the square root of 2 over 2. And then pi over 3 is up here, and let me just kind of draw over here. That cosine is the square root of 3 over 2, and the sine, I'm backwards here, the cosine is 1/2, and the sine is square root of 3 over 2. All right. Then we're going to take the cosine of pi over 3 minus pi over 4. The identity up here, it's minus, so I'm using this one. I need to take the cosine of the first, so I'm going to take the cosine of pi over 3 times the cosine of pi over 4 minus the sine of pi over 3 times the sine of pi over 4. Okay, I am writing on the paper there. Checking the frame there. Now cosine of pi over 3, that's right here, is 1/2. So I got 1/2 times cosine of pi over 4, square root of 2 over 2, minus the sine of pi over 3, which is square root of 3 over 2, times the sine of pi over 4, which is square root of 2 over 2. And I'm going to work down here now. These, you just multiply the numerators. That's the square root of 2 over 2 times 2, which is 4, minus, now square root of 3 times square root of 2 is square root of 6, and 2 times 2 is 4. We've got a common denominator, so I'm going to rewrite this as the square root of 2 minus the square root of 6 over 4. And that's as good as it gets here, guys, as far as the answer in that we're using. All right, second example is sine of 75 degrees. I think I want to use addition on this one. And the goal is use, and this is in degrees, use values that are on the unit circle that will give you this with addition or subtraction. Now, the thing that hits me is 30 degrees and 45 degrees for the sine of 75. And that adds up like we want it to. And so now I already have the pi over 4, which is the same as 45 degrees. So I already got that one over there, so I'm not going to redraw that part. The cosine here is the square root of 3 over 2 of 30 degrees, and the sine is 1/2. So let's write out this identity. Well, yes, let's write this out. Sine of u plus v. Here's u, here's v. If you're coming up here, the very first one we have, that's the sine of 30 degrees times cosine of 45 degrees plus the cosine of 30 degrees sine of 45 degrees. And this is addition. This is our sum of sine identity we have. Now, sine of 30 is 1/2 times cosine of 45, that's square root of 2 over 2, plus cosine of 30, that's square root of 3 over 2, times sine of 45, which is square root of 2 over 2. And I'm looking at square root of 2 over 4 plus square root of 6 over 4. And as one single fraction, we have that common denominator. That's a nice thing. I've got square root of 2 plus square root of 6 over 4. All right. Example number 3. Let me turn the page here. All right. 7 pi over 12. I'm doing tangent. And I just went back here. Remember, 4 plus 3 would be 7, right? So 4 pi over 12 plus 3 pi over 12 is 7 pi over 12. Let me use that fact here. So tangent of 7 pi over 12 is equal to the tangent of 4 pi over 12 plus 3 pi over 12. That's how I'm breaking up 7 pi over 12, because those are two values, again, that are on the unit circle. I may have to be flipping. I don't have the... let me simplify those into more recognizable forms on our unit circle. pi over 3 plus pi over 4. Okay. Now, the identity we're going to use, the tangent of pi over 3 plus pi over 4 equals, let me just take a quick peek at it. Tan u plus tan v over 1 minus. Okay. So it's the tangent of pi over 3 plus tangent of pi over 4 over 1 minus the tangent of pi over 3 times the tangent of pi over 4. And let's see. Let's think about what those are here real quick. All right, tangent of pi over 4 is 1, because that's the square root of 2. That's sine over cosine, and both of those are square root of 2 over 2. So the number over itself is 1. Pi over 3, that's up here. The sine is, well, the cosine is 1/2, and the sine is square root of 3 over 2. When I do sine over cosine, I've got square root of 3 over 2 over 1/2. We've done a lot of simplifying with that. Those 2's cancel out. So the tangent of pi over 3 is square root of 3. Tangent of pi over 4 is 1. And then that's 1 minus tangent of pi over 3, which is square root of 3, times the tangent of pi over 4, which is 1. So I've got everything substituted in here now. So I'm looking at square root of 3 plus 1 over 1 minus the square root of 3. Oh, I'm already starting here. It might have been a good idea to switch those around. I'm not going to do that right now. Actually, I am. I'm changing my mind, and I'm allowed. So I'm going to make this 1 plus square root of 3 in the numerator here. Okay, just rearranging the order so that we have the number and then the radical. And we have to rationalize the denominator. In this one, we need to use the conjugate. Let me change colors here. We're going to get fancy. Let's go 1 plus the square root of 3 on that one. And when you do it to the bottom, you got to do it to the top. And, okay, I'm going to FOIL here. 1 times 1 is 1. Plus 1 times radical 3 plus 1 times radical 3. I'm doing the outside, the inside, and then the last. Square root of 3 times square root of 3 is 3. All right, I'll simplify that here in a second. Now, we did this because 1 times 1 is 1. And then you've got your negative, this outside is positive square root of 3. The inside is negative square root of 3. Those guys are canceling out. You can FOIL it out and write that yourself, but I'm not going to right now. I'm going to just put it minus the square root of 3 times square root of 3, so it's 1 minus 3. And 1 plus 3, that is 4. Radical 3 plus radical 3 is 2 radical 3. And 1 minus 3 is negative 2. And if I just go through and divide both terms, I'm going to separate them. Maybe I should show that. I'm taking 4 over negative 2 plus 2 radical 3 over negative 2. I'm doing that because we're going to lose the fraction anyway. So 4 divided by negative 2 is negative 2. 2 divided by negative 2 is negative 1. So I'll just go minus radical 3. All right, there's my simplified version there. All right, one more example. I hope you saw that. It just occurred to me I may have had that too low below the camera. Last example, find the exact value of sine of 7 pi over 6 times cosine of pi over 3 minus cosine of 7 pi over 6 times sine of pi over 3. I wonder what that might be. And when I look, sine, cosine minus cosine, sine. They kept the angles in the same order. Sine, cosine minus cosine, sine. Sine, cosine, oops, that's plus. Sine, cosine minus cosine, sine. So I'm using subtraction here. Just kind of going in reverse. Sine of 7 pi over 6 minus pi over 3. And that's 7 pi over 6 minus 2 pi over 6, which is the sine of 5 pi over 6, because that's what 7 pi over 6 minus pi over 3 is. And that's a 6. Got in a little hurry there. Unit circle time. Sine. We're 5 pi over 6 is over here. Sine's positive. Looks like the y-coordinate is 1/2. Sine of 5 pi over 6 is 1/2. So this exact value is 1/2. All right. Let me explain the assignment. You'll be working on page 538. Now, do you notice the little s, c's, and t's? The instructions say find all three. That's a lot. I'm taking a third of the problems away from you right here. But just kind of go sine, cosine, tangent, sine, cosine, tangent, sine, cosine, tangent with those. And then do all of 35 through 40. It's similar to that problem right there. This is due, this is posted before Monday here, this video. The assignment is due 11:59 p.m. on Tuesday, the next day. So I just want you to know that I'm going to give a video on Mondays and Wednesdays, and then you have till Tuesday the next day on the Monday video to get the work done, and you have till the end of the day on Thursday to get the Wednesday videos done. And so we're actually doing about half of what we thought we would be doing before, but it is still keeping us in practice and keeping us fresh, and I hope to see you in early April, guys.